All right, let's look at a problem. This is a pretty simple problem to state, but it's kind of an interesting problem and has some interesting ramifications. So it asks, what's the minimum number of equal forces that we can add to equal a vector sum of 0? Well, if we are adding our forces up, that means Newton's second law says if we add our forces up, it provides us with an acceleration. So I'm looking at these things going, okay, how many forces can I add? What's the minimum number? What's the maximum number? Well, in this case, I want to add all my forces up to give me 0. I want an acceleration equaling 0. So if I were to draw a free body diagram for this, if I were to put one force, some random force on here, and ask myself, what happens to our equations? Say this is in the x and the y direction, positive x, positive y. Well, Newton's second law really is a combination of three equations. There's a sigma f in the x direction, gives us our acceleration in the x direction. There's a sigma f in the y direction, which will give us an acceleration in the y direction. And last but not least, a z direction, giving us an acceleration in the z direction. So there are three equations that come out of this general one right here. If we have one force in the x direction, then we would have to have an acceleration in the x direction. If this guy is not 0, then this thing cannot be 0, unless we have no forces on an object that has 0 mass. But we don't have that. We're putting a force on a real object, an object that has some matter in it, some mass, and it's providing us some acceleration. So we can't do one. If we have a force, one force means that we have a net force. That net force means we have to have an acceleration. So it's kind of a nice little thing to stick in the back of your head. If you have one force, you have to have an acceleration. Your velocity has to be changing if you have one non-zero force. If you have two forces, then you actually have to do this sum. And there's actually a way to solve this problem. If we have one force in this direction, if I were to put another force exactly opposite, then when I would go around, I would say this would be in the positive x direction, this would be in the minus x direction. So in my x direction, I would add up my forces like Newton's law says to do, and I would say force in the positive direction, a force in the negative direction, and that would provide for me the acceleration in the x direction. Nothing in the y, nothing in the z in this picture. And this value right here is 0, which means if my mass is, some object has mass, then that means that this acceleration has to be 0. So our lowest number of forces, of equal forces, to add up to a vector sum of 0 is 2. If we have at least one non-zero force, we need at least one other non-zero force. It has to be equal and opposite of it, actually, to cancel it out in order for us to get 0 acceleration or 0 vector sum.